Hello everyone, welcome back. Today we are going to build on our existing knowledge of functions by learning about modules. The great, possibly the best thing about Python is there are tons and tons and tons and tons of pre-written functions which have been already written by somebody else, probably multiple someone else's, and these functions are stored in modules. And you can use all of these predefined functions. All you need to do is just import them. So one of the most popular modules is something called NumPy, and this is going to allow you to do numerical operations with arrays. So let's go ahead. In order to use NumPy, what we need to do is we need to import it. So we import NumPy. NumPy stands for numerical Python, by the way. So we want to create an array of 4 zeros. We then type in NumPy dot zeros 4. This is going to create a list-like object that's actually a NumPy array. We're going to give this a name x, and then we're going to take a look at x. And we see that x is an array of 4 zeros. We didn't have to write the zeros function. We just imported it from NumPy, and we can use it right away. Now, the thing about modules is a lot of them are really big, so some of them have submodules. So we're going to use the random submodule from NumPy to create a random array of random 5x5 array. So we're going to say a equals numpy.random.rand 5x5 and take a look at a. Oh, sorry, I called numpy mp as an old habit. As we will see later in the course, it is very common to abbreviate certain modules, and numpy is usually referred to as np. However, so we type in numpy.random.rand 5x5, and out pops a list of 5 numbers. If we want to look at what this looks like, we can use the plotting functions from matplotlib. So we do from matplotlib import pyplot. And then we can use pyplot.imshow to show the image. And we see a nice random 5x5 image. Now, as I mentioned just a second ago, it is extremely common for these modules to have standard nicknames. And you'll almost never see somebody write what we've wrote in above. Instead, what you'll see them write is something that's slightly different. It'll say from matplotlib, import pyplot as plt. And then down here, they will just write plt.mshow, and this will work exactly the same way. After this video, we are going to always refer to pyplot as plt and numpy as np. Because honestly, it's so standard that, as you've already seen, it's almost hard to not use it once you become an experienced programmer. So this is all well and good, and we've got all these pre-written functions, but we want to be able to make sure we learn how they work. And so we can do this by reading their documentation. And you could go around the internet and Google and Ask Jeeves or whatever your favorite search engine is. But Python actually makes this really easy just to look at. So all you do is you use question mark. And say we want to learn how numpy.zeros work. We would type in question mark numpy.zeros. Ooh, I forgot the S. And okay, up pops this beautiful doc string. Says zeros. There's positional arguments, shape. Then there's an optional argument of float and an optional argument of an order of C. And then it says shape will be an int or doubles of ints. And so for example, if it's a 2x3, it'll give us a 2x3 array. Data types are optional. And then you can pick the order to be C or F, which is just whether or not to store multidimensional data in a row major or a column major style in memory. And we don't really care about that, but the point is that we can type in a question mark numpy.zeros, and out everything pops just like we like. Now, the important pitfall to avoid is not to do this. Do not type in numpy.zeros parenthesis, because then it'll be confused. The name of numpy.zeros is just numpy.zeros. You add the parentheses when you're trying to call the function, but we're not trying to call the function. We're just trying to learn about it. So we don't call it, we just say its name, which is numpy.zeros. So you may have noticed that so far we have been breaking the first rule of Programming Fight Club. We have not been commenting our functions, and this is very, very, very bad. As you likely have learned in your introductory class, and if you did not, I am mad at whoever was teaching your introductory class. Whenever you write a function, you should comment it. We have been doing bad things and not commenting our functions. So let's fix this problem. Let's become good programmers and stop doing what we're not supposed to. So here's our function we wrote last time. It prints a message multiple times. And now let's add some comments. So typically for function comments, you're going to do the triple single quotes and then split it apart in lines. And now we're going to write some things. So it prints a message a specified number of times, parameter 1, parameter message, the message we are printing, parameter, spell parameter correctly, n, the number of times we are printing it. And now this is going to work exactly the same as before. But what's super nice is now if somebody else wants to use our function, they can now type in question mark, print multiple times, and up pops our docstring. We just wrote this, and now they can say, this prints a message a specified number of times. The parameter message is the message we are printing, and the parameter n is the number of times we are printing it. Now, the great thing about Python is that other people have pre-written code, and you can also write your own pre-written code for other people to use. We're building a community where we all have these great functions that we can all use. And therefore, it's very important to document your functions. Now, we could even go a little bit crazier, and we could go ahead and write our own module. This is not something we're typically going to do, but it is something that I want you to learn how to do. So the first thing you do is you write your code in a nice triple quote like this. I've got quote is def square of x, and we've now documented our square function. It computes x squared, returns x times x. And we're going to now create a new file called square.py. So I'm going to do this. I say file equals open my module.py. W stands for write. And then we are going to write our code in the file. So it would have been file.write code. This is the code I wrote up here. And then we opened our file, so we should close it. And now what we can check is go take a look at the file, the folder you were writing this in. I'm looking at my folder right now, and I can look at it, and I can see there is no folder called mymodule.py. Go ahead, look at your own folder, make sure there's also not a folder called mymodule.py. Okay, now let's press enter. And now look at your folder again. I'm looking at my folder again, and I see that there is now a file there. It's a py file called mymodule. So we have now given life to a brand new module, which is named mymodule.py. And now we want to use the functions from our module. So first what we need to do is we need to import my module. And now that we've done this, we can then type my module dot square of 3. And we have now computed 3 squared. Although there is a caveat that you do need to spell my module correctly, because being a poor typist will make you get lots of error messages, as you will learn many times from watching me attempt to type and talk at the same time. Sorry. Alrighty, so the last topic for today's lecture is args and kwargs. And so you could write a function which adds 2 numbers. You could write a function which adds 3 numbers. If you really wanted to, you could write a function that adds 15 numbers. But it'd be kind of nice if you didn't have to write a new function for every single different possible number of inputs. And so the way you can do this is using args. So we're going to write an adder function, which is going to be called add. And now this is what we type in here to say that there's going to be some number of arguments and we're not going to specify in advance. You write star args. And the star args command allows you to have an arbitrary number of inputs. Yay. Okay. So now we're going to start off with total equal to 0. And we're going to say for a in args, total plus equal a. And then we are going to return our total. And as you may have noticed, I misspelled the word for. But now this should work quite nicely. So after we've done this, we can now add up an arbitrary collection of numbers, and we get 23, which you can check that 2 plus 3 plus 4 plus 5 plus 2 plus 3 plus 4 is indeed equal to 23. No, I did not know that in advance. That's why I wrote the function. So kwargs is similar to args, but it's even better because it lets you specify an arbitrary number of key-val pairs. So we're going to first do kind of a basic example, and then we're going to do a really powerful example. So our function is going to be called def print capitals. And we're going to input kwargs, which is going to be an arbitrary number of key value pair arguments. And we're going to say for key val in kwargs dot items, because it's going to assume that kwargs has a dictionary-like structure. Print val, or the capital of plus key is val. And we need to enclose things in quotes and properly do string concatenation in order for this to work. So now we can go ahead and run this, and we can print out that the capitals, the print capitals, and we are going to say California, the capital of California is Sacramento, and that the capital of Massachusetts is Boston. And it now says that the capital of California is Sacramento and the capital of Massachusetts is Boston. Something to note is that if you are using args and kwargs together, args must always come first. And this is because as we've already seen, keyword arguments always have to come last, and kwargs is for keyword arguments. So in the next example, we're going to use kwargs in a more powerful way to create a beautiful scatter plot. We are again going to use pyplot. So if we hadn't already ran this line of code from matplotlib import pyplots plt, we would need to run it again. However, we've already run it, so we don't need to run it again. But we do need to import a new function called random, which is going to let us use random points. So we can create a random scatter plot by saying def random scatter n. And in our first version, we're not going to use kwargs. We'll add in the kwargs later. And this is going to produce a random scatter plot. Parameter n is the number of points we are plotting. Okay, now we're going to create a random list, 2 random lists, x and y. So we got x is going to start off with initial and y is equal to empty. And we're going to say for I in range n, x dot append random dot random And y dot append random dot random. Probably should have just copied and pasted there, but I didn't. And now we're going to go ahead and we are going to plot. We're going to use plt.scatter to make a scatter plot, and we're going to scatter plot our x and y. So let's go and make a nice random scatter of 100 points. Out pops a relatively nice looking picture where we've got 100 points all scattered all over the screen. But say we wanted to betterize this function and we wanted to get orange points, because I know I don't like blue points. I like orange points. Well, but we also might want to make the points bigger or smaller or more transparent, less transparent. We really don't know how many different other things we're going to want to specify. So we're going to make this function betterized by using kwargs. Star, star, kwargs. And then the only line here we have to change is we're going to pass these kwargs into the scatter function here. So function's almost the same as before. Random scatter n kwargs. And then we've got a parameter n, then we have a new parameter kwargs. Parameter kwargs are passed into pyplot's scatter function. And now we can rerun this same code, random scatter, again with 100 points, but say that color is equal to orange. And so now this looks basically the same, but these are nice, beautiful orange points. No more blue points. Blue points are for suckers. Okay, but you know what? You know what's even better than orange points? We could do red points. Color equals red. Okay, but these points also, they're not big enough. Let's make them 100, and let's make them a little bit see-through. The alpha parameter corresponds to how transparent things are. So I'm going to set alpha equal to 0.3. And now we have these partially transparent, very big red points. And we didn't have to know all of this stuff when we were writing the function, random scatter. Up here, I did not say anything about alpha. I didn't say anything about color. All I just said was there's going to be some keyword arguments, star, star, kwargs. And we didn't know about that when we wrote the function, but nonetheless, we can still use them. So this is just generally great. And the last thing we're going to do before we end the video is just check out how many potential arguments there are for this random scatter that we have gained access to. So let's take a look at plt.scatter. And once again, Python only works if you spell things correctly. But once you have plt.scatter, okay, so there are all of these possible parameters you can use. And typically you're going to want to specify a lot of them, but not all of them. And kwargs is the great way in order to do this. So this is where I'm going to stop. I will see you again next time.